It's like, oh, not the map thing that you used to keep in the back of your car.
Yeah,
the real storybook atlas.
Yeah. Well, better than oh, now I can't think of his name now. Sisyphus, right? It's
yeah.
Yeah.
No, at least I can spell it.
I was thinking Vesuvius, but I'm like, no, that's a volcano.
That's a thing. That's a thing.
Or city. No, volcano.
Yeah.
Anyways, so welcome. This is the Ask an OpenShift Admin Office Hour, which is one of the Office Hour series of live streams here on Red Hat Live Streaming, which means that we're here for you all. We're here for our audience. Ultimately, our goal is to answer any and all questions that you have around OpenShift. Chris and I are both administrators by trade, or we were at least a little while ago.
Yeah.
And that is where much of our expertise comes in. And that's why this is Ask an OpenShift Admin. So please don't hesitate to ask us any questions, anything that comes to mind, and we are happy to do whatever we can to get those answered. If that means we can answer them here on the stream, we'll do our best. If we can't, if it is something that is outside of our area of expertise, or we need confirmation, we will reach back into those resources here at Red Hat. So engineers love hearing from us, along with product managers and everybody else. We'll get those answers and we'll follow up. So Christian hiked Mount Vesuvius.
Did he really?
Neat.
Oh, wow. That must have been crazy.
All
right. Clearly he was not there for the eruption. But
well, it was a minute or two ago. So
yeah. Jeez, my brain is just off. All
right. More coffee needed.
Yeah, no, I've just made some.
Yeah,
it's gonna be like a 3-pot day, not a 2-pot day like it normally is. I feel like. Anyways.
Well, in the absence of any questions, or in addition to any questions that you all happen to have, we also have a topic. We try and focus each stream on something that we can use to help educate and oftentimes learn ourselves. Every time I do one of these streams, I learn I learn new things, it seems like. So this is certainly no exception today, where we'll be talking about disaster recovery. So this is kind of we didn't call it a multi-series or a multi-part series, but this is kind of the follow-up to our episode or our stream last week, where we had Christian Hernandez on to talk about high availability with OpenShift. So if you didn't see that previous episode, you can find it across all of the streams. Or all of the platforms, I should say, YouTube, both the OpenShift and Red Hat YouTube, as well as Twitch. There's also a blog post on, what is the new? It's cloud.redhat.com/blog.
Yes.
Or if you go to openshift.com/blog, it'll redirect.
Right.
But every week we have a blog post that comes out that we link all of the information, as well as to timestamps for when we talk about certain things. So I'll include a link to last week's episode in this week's blog post as well. We also have, I'm gonna start calling it a segment. I think that feels appropriate at this point, because we've been doing it basically since like episode 2 or 3. What I call the top of mind topics.
Yes.
So these are things that they have happened in the last week or two, right? Usually since the last stream, things that have come up that I feel are important to you all, or should be important to you all. So messages that we want to get out, things you should be aware of, right? That type of stuff. And of course, as is no exception, today we've got a few things. So let's see. The first one that I wanted to bring up at Chris's suggestion is the Cloud Tech Tuesday stream that happened yesterday.
Yeah. I'm going to drop that in chat for y'all here.
Yeah, please do. So I'll let you talk about the details of that stream. It's one that I actually need to go back and watch.
Yeah, so we had team members on from the Kubernetes 122 release team, which is the first Kubernetes release in the new release cadence of 3 Kubernetes releases a year versus the traditional 4. So it was interesting to get their insight in not only some of the interesting things that came out of 122 or the release itself, but B, kind of like how the sausage is actually made, and like how we constantly in the Kubernetes community try to improve on the release process, right? So the release team works with a release SIG to make Kubernetes actually go out the door, right? So there is like a continuity group behind it, but the team is not comprised of solely SIG release members. It's comprised of volunteers from across the spectrum of experience. So you could be a non-code contributor and easily participate in a release. You know, they need to send emails, they need to send comms like everybody else. So, you know, that's a great way to figure out how to get involved. And like just having that team on yesterday gave me a lot of energy and life and so forth. So please check out that video and you know, let me know what you think. And if you have any questions about the release process or anything like that, feel free to hit me up, Short at Red Hat, or Chris Short on Twitter with 2 S's. And yeah, I can definitely plug you into the community as need be. But yeah, it was a super insightful episode.
Is this when does Kubernetes switch to the 3 annual releases?
This was the first one.
Okay.
So the next release is not for another 4 months as opposed to 3.
So it'll put us out in January.
Right. So, but this also means now that when we, quote, deprecate something, that does not mean remove in Kubernetes. That just means it's going to be removed soon. So that's a good delineation to kind of keep in your head, right? Like deprecated does not mean removed. But now when something is deprecated, you have a full year to replace or upgrade it, right? Because sometimes an alpha API is deprecated and the beta API comes in, or the actual, you know, V1 API, the production grade API, gets upgraded from beta to just generally available. So like those little subtle changes in group version kind really, really matter, especially when like, you know, oh, we just updated our OpenShift cluster and oh, there's some apps that are not working for some reason. Oh, well, that this API got, you know, deprecated or upgraded or whatever. So understanding that process, I think, is very important, right? So deprecation does not mean removal. It's deprecation and then eventual removal 3 releases later, which equals a year now. So before it was 3 releases later, that was only like a handful of months. So you had to act very quickly. Yeah. And I'm sure, you know, OpenShift will adopt a similar kind of cadence potentially. We'll see. But yeah, all the new things in Kubernetes 122 we talked about yesterday, we asked everybody the favorite topics and everything else. So please check out that video. I think it'll be very insightful for everyone.
Yeah, and I took the opportunity to share my screen here.
I see that.
Yeah, so this is the What's New in 1.22 blog published by our product marketing team. Yes. So Karina here is credited as the author, but this was I wouldn't say I participated, but I was aware of the draft, and I know that there was like half a dozen at least of the PMs who all contributed into this. So definitely worth a read if you haven't seen it yet. This is also kind of a predictor of the things that we are interested in and that we care about in 1.22. So when 1.22 gets incorporated into OpenShift, so 4.8 is 1.21 based, so you can kind of guess when that might be. It just things to look forward to, things to be aware of coming up. The other thing, and I'll use this opportunity to, let's jump back to the blog. And if I scroll down here to, so here's last week's blog post around the stream. Remember I said at the top, a little cheat here that I talk about sometimes. If you select the category, OpenShift.tv, all of these show up. And what I'm looking for here is one of these streams in the top of mind topics. I talked about, and I use this, I do this all the time, right? I dig through my own blog posts to look for things that I was looking for.
My website is actually a reference for me, not for y'all. It just happens that it's public and it's more of a reference for me.
So one of these talked about, and now I can't remember the command, and this is why I'm looking for it. The ability, there's now in 1.21 / OpenShift 4.8, we can go back and we can see which APIs are being called. Do you happen to remember what command that is off the top of your head?
Oh, no. And I remember like us talking about it and it was super cool, but I totally forgot to write it down.
Yeah. So anyways, I'll see if I can dig that up at some point because I'm not seeing it while I'm talking and half reading. But there is a way that you can go in and you can query. It's an OC command. It basically says, hey, show me all of the APIs that are being used, including the deprecated APIs. So it's a great way, as Chris was just saying, with 1.22, when we start making API deprecations, you can immediately see whether or not those are being used and whether or not you need to take action with any of your applications or anything like that inside of the cluster. I will say that sometimes those are operators, right? Our Red Hat's own stuff that are using those APIs, which that'll get fixed. I don't know. I don't think there's a way that you can identify which is which.
Hang on. Oh, no.
No, it was worth a shot.
Oh, I upgraded my cluster and I didn't bring the kube config over from that box to this box. But yeah, it's OC API dash resources.
So that one I know will print off all of the APIs that are in the cluster. So let's open this guy up.
So you got to like namespace scope it, I think, to.
So like if I do OC API resources, see, it tells us all of the APIs that are available, but it doesn't tell us whether or not they're in use.
Right.
So I use this one frequently to identify like a CRD that's associated with a specific thing. So like I can do OC API resources and grep for storage, for example. And I can see all of the things that are associated with, storages. So yeah, we'll have to dig up that command. I don't remember what it is. Let's do this. Maybe API resources dash help.
Yeah.
Sort by API group extensions. Yeah, this is.
If you did namespaced and true, it would tell you per namespace everything that's in use, I think. But yeah, I think I think we need a Christian to get off the weight rack real quick and tell us.
Yeah. We'll figure it out. I'll share that at some point.
I'll include it in the blog post.
Yeah. So I'll dig that back up. But it is newly introduced in 4.8. In fact, that might be where it might be the blog post that it's in. Now that I think about it, I'll take an extra 3 seconds here to go back. Not quick start enhancements.
No. Not import multiple YAMLs.
And now I clicked on the wrong thing. Yeah, here we go. High availability, OpenShift TV, authentication 4.8. Here we go. Let's try this one. Sandbox containers, VPA. Which APIs are going to be removed in the future?
Okay.
So
you got a link to
OC get API requests command. There we go.
OC get API requests.
Wow. Okay. Well, who am I?
SCP some stuff over now.
Well, now I just proved myself wrong. That let's see, get API. No, not gonna work.
API is it?
There we go.
Dash requests.
Apparently, I need to use the full object name.
Wow.
So I will copy and paste that guy over here just to be clear on it. Anyway, so we can see that this one. And you see, we'll scroll all the way up to the top, requests in current hour, requests in last 24 hours. Then we have this removed in release. So if we scroll down here, we can see this ingresses v1 beta 1.extensions is removed in 1.22. So this would be an indicator that there's something that is poking that API. And hey, you need to look for that because in the next release, it's going to be removed. Coming down here, here's mutating webhook configurations, v1 beta 1. So it's a good one to have just to be aware of. Again, I don't think that there is a way to tell like what is actually poking those API endpoints. That would be very helpful. I would love to be proven wrong on that, however. So if anybody out there happens to be digging around, please don't be shy and share.
All right. Well, I'm getting a certificate error from my cluster, so never mind today.
Yeah. Well,
I just rebuilt that thing this weekend too. Well, I had a lot of power outages, right? So like RAID 10 is great, right, for keeping your disk in place. But if you don't take snapshots, kind of don't have anything to restore from when that one VM just Besides, I'm not coming back up from that power
Snapshots
outage.
are not backups, but they are good point in time recoveries.
Yeah, like that's really all I needed. So I ended up losing a master or control plane and a worker node, and it was just like, and
Christian, approve the CSRs. Yeah.
No, it literally was the disk corrupted. Christian, I actually sent you this error, and you were like, "Ooh, dude, that's a bad disk." So.
All right. So the second thing I wanted to bring up this week is somebody asked, because I've shown this page before. So this is the CI release page. If you've never seen this, I use this to cheat sometimes and look at what's coming in releases, right? I can click on one of these guys and I can come down and see what's changed from release to release. I can get an idea of like what version of CoreOS is being used. I can see, right, all of this information in here. So for me, it's useful because, oftentimes I'm kind of at the bleeding edge of what's going on in OpenShift. And that's, being aware is always important. However, you'll notice that we call this for stable. And we have basically every OpenShift release that's listed inside of here. But if we compare that to, all right, so I'm going to switch over to console.redhat.com now.
Okay.
So if we compare that to the releases over here, you can see releases with 4.8, we've got 4.8.4 is the current stable channel. Fast is 4.8.5 and candidate is 4.8.6.
But I see a 4.8.6.
Yeah. So what's the difference between the stable that's listed here on the CI page and the stable that's listed over here on the releases page? And the answer to that is complex, not super complex, but it's not as straightforward. It's not as simple as, always do this or always do that. So the way that this is defined, this stable is defined, is it has passed all of the CI tests and is capable, right? It can be used to deploy new clusters. That doesn't always mean that it is a supported deployment, however. Right. So, for example, you'll notice there's like RCs in here and FCs, right? FC is feature candidate, RC is release candidate, or feature complete, maybe something like that. Anyways, obviously, an RC is not a supported release, even though technically you should be able to deploy this because it's all green over here. You should be able to deploy it without issue. So just be aware that stable in the CI release is not the same thing as stable over here. Right. And stable over here, a release hits the stable channel when we have confidence in its upgrade status. So what I mean by that is oftentimes, and we see this today, right? Yeah. Where the first OpenShift 4.8 release that was in stable was 4.8.2. And we feel that, for example, 4.8.4 can move into stable because upgrades from 4.8.2 are successful, right? We have confidence in that. And of course, that is fully supported because it's stable. Same thing with fast, fully supported. So, but that isn't always true. So, which brings me to the next top of mind topic for this week, which is updates or upgrades from 4.7 to 4.8 are currently still blocked as a result of a bug with the authentication operator. So to close out the previous thought, generally speaking, you always want to go by what you find inside of this page, right? For which releases you want to use for deploying clusters, right? If you want to deploy a stable cluster, just come here and find whatever the current version of stable is, and then go from that. If you have an existing cluster, right, use whatever release channel that you want. So whether it's stable or fast for supported versions, right? Pick that and then use a version that is inside of there. You can use these releases. Just be aware that you could end up in a situation where you have deployed an unsupported release and there is no supported method to get to a supported release. So for example, I could deploy RC3 today, set it to the candidates channel, and then update to like 4.8.6. None of that is supported, even though it's all here in this quote unquote stable. So apologies for or hopefully that eliminates confusion. Apologies if it creates confusion. Please don't hesitate to reach out. So going back to what I was saying a moment ago around the releases. So if we were to look, so I am on the Cincinnati Graph Data GitHub page, and rhope9, I see your comment in there.
Oh, yeah. Let me read that real quick.
Yeah, we'll address that in just a moment. Yep. So I'm on the Cincinnati Graph Data GitHub repo. So this is where the clusters pull their update information from. So if you were to go into your cluster, I happen to have a cluster here. Let's close that guy. Yep. And I come down here to cluster settings, right? So the data that's found inside of here, these values come from what we find over here in these various locations. So for example, if I go to channels and I go to stable 4.8, you can see that I can update from 4.8.2 to 3 or 4. If I come back here to blocked edges, however, and we scroll all the way down here to 4.8.4, you'll notice that anything from 4.7 is blocked. And it's a result of this particular BZ. So we'll paste that guy in here. And I'm not going to dig through the details here, but essentially it's, authentication operator fails to become available during upgrade. You see that this started back in 4.8.2 back in late July. If we scroll all the way down here, you can look through the comments and read through them, but more or less, they're continuing to see this, or they continued to see it in a few clusters that were being upgraded from 4.7. So they decided to go ahead and block it. So that way we could prevent it from becoming an issue for anybody. And this, if we look at these two particular comments, we're seeing that this appears to be fixed in 4.8.5, which is not yet in stable, right? It's still in fast. So just be aware. All right. Have you had time to?
Yeah. rhope9 is, so they're looking for the TLSCA bundle.pim for the API so they can remove the insecure skip TLS verifies, flag and actually get their money's worth from the CA in OCP. So thoughts, I have a few. And they understand that there's documentation on how to replace the CA, but like that internal CA is.
We'll probably have to reach out, phone a friend to get an authoritative answer on this. So my understanding is that replacing the CA, and I guess, and I'm going to assume that this is specific to the ingress and the wildcard certificate and the API certificate.
Sounds like they're looking at just the API server.
Okay. So
yeah, and Christian says I would just replace it with my own.
Yeah,
I kind of agree. It's basically re-encrypt. Yeah.
So essentially you can replace the certificate, but I don't know if we can replace the CA so much as just ignore it depending on what's being used.
Right.
So yeah, you would effectively, and I don't remember where it's at inside of here.
Yeah, you search for if you search for .pim,
replacing the default ingress certificate. And I'll post this in here. Although I know rhope9, you said you were aware of the docs, but so we can reach out and we'll ping our subject matter experts on this. Yeah. But off the top of my head, and you can see here's replacing the trusted CA with so that's the one that it's trusting from a proxy.
Adding API server certificates. Click that one on the left. Sorry.
Yeah, create a TLS certificate. Okay, blah, blah, blah. Yeah, I'll verify this and whether or not we can replace it. As far as I know, it should be entirely possible. And you can see this would be the command that we would use to replace that with your own certificate. But the weird thing here is it's creating a certificate here. So this is almost like a manual rotation. That's weird.
It's kind of weird.
We'll find out what's going on here.
Yeah, it's not cut and dry exactly how to solve this problem. So that's why I wanted to discuss it on air. And then, we'll take it up with the powers that be, AKA our PMs and engineers.
Yeah, we'll find out what's going on here. If I can get an answer soon enough, keep an eye on the blog post that'll come out. Usually Friday mornings is when they get published. I'll also add it to the notes for next week. So we'll talk about it in the opening segment for next week. So the last couple of things I just want to quickly roll through because of time issues. So the first one, Chris, actually, you highlighted this to our team, which is the GitOps catalog.
Yes.
So this was an interesting one that came from, we talked about GitOps last week with Christian on, and Christian also has GitOps Guide to the Galaxy, his live stream, which is every other week. So it is not this week, it is next week, I believe.
Yes.
Anyways, you can see the Red Hat COP, which is the community of practice inside of Red Hat. So a group of subject matter experts based in the fields, right? Passionate people who are interested in these topics. So the COP has this GitOps catalog, which just has a huge number of different examples, right? Things you can use. And you can, if we scroll all the way down here, it tells you, right? Not officially supported by Red Hat, right? It is COP, not official Red Hat. So it is Red Hat folks that are contributing to it, but it is not an officially supported Red Hat thing.
Right.
And then you can also see customers are encouraged to take individual items of interest into their own curated catalog and maintain it. But anyways, I think this is a great place to start, just learning GitOps, how to interact with GitOps, how to use GitOps for a huge number of different things that can be done inside of here. So I don't know if you have anything to add there, Chris.
Yeah, I mean, this was a collective effort between, Christian, the GitOps team, the Red Hat Canada folks, right? Like it's been a lot of work has been put into this to kind of give you example ways of implementing these various tools in a GitOps way, right?
Yeah.
So using OpenShift GitOps, these should kind of like work out of the box, once you fill in all the variables and everything else you need to make it unique for your environment. So yeah, it's not officially supported. I want to make that abundantly clear, but it is a great way to get a look because I learned by example. If you want a good example, this is a great place. So please reference it. I mean, you can see the contributors on there, include Christian, include Andrew Block, lots of, very smart people like Andrew Pitt, Gerald Nunn.
I hear a lot of Andrews in there.
Yeah. Yeah. And it's really, really nice because it uses a lot of customized too, which is, something that I can work with very easily. So I really appreciated this effort on Christian's and the whole GitOps,
COP.
Internal team we have, COP here. So yeah, big kudos to that team and check this out. It is very, very cool. It's a very good way to see like, okay, how do I get from A to working in GitOps?
Yep. Definitely check out that link. And I posted it in the chat. It will also be in the blog post. I know I keep saying it.
Yeah.
So the last one for this week, I will quickly post this over here. So this is a link to the release notes, which were just updated. So this is
probably 4.7.
Probably should have. Yeah. So I probably should have highlighted this before. It's hard to see. This is OpenShift 4.7.
Yeah.
And if we come down here, you can note that our RCOS, right, CoreOS now is now based on 8.4. So just be aware in case you encounter any issues. I would think you wouldn't, but just in case, we did rebase from RHEL 8.3 to 8.4. So if you are also having issues with drivers, right, I've had a couple of customers over the last year or so say, hey, I need this version of RHEL because it includes this driver for my hardware. Well, now it works. Or now you might have access to those. So.
Yes, and our Hope 9 says also shout out to the new console page. So
yeah,
all the folks working on that, there's your kudos for that. I know that has not been a trivial effort. So thank you.
Yeah, we have a monthly meeting with that team and they're doing great work.
Yeah, they really are. I can't say enough good things about them. Trying to serve everybody's best needs is very hard. So yeah, thank you for the work there, folks.
Yeah. All right. I am going to stop sharing for the moment. Cool. So disaster recovery.
Yes.
And I know we've got about 30 minutes left. We do have a hard stop today, so we'll get through as much of this as we can. I've got a massive note stock on this topic, as Chris highlighted to me before we started. So I'll take all of the information that I have in there. And again, it'll be in the blog post. So even if we don't get to it, I'll include all of that. I'll include any links, any other information that we have inside of there. So first, I want to start with kind of recapping what we talked about last week. And this should hopefully be just a brief recap of, kind of what is the difference between disaster recovery and high availability. And I don't know if we ever actually used this term or this phrase last week, but we kind of, beat about it from all sides, if you will. And that is, in my opinion, and I think you agree, high availability is generally a partial cluster failure, right? Some aspects of OpenShift and all of the supporting things are still there. We just need to tolerate that loss in capacity or some loss in functionality. Disaster recovery, in my opinion, is typically, it's all gone, right? The whole cluster is now gone. So how do I now bring back my application? How do I now recover the application's functionality? And that's not to say that a high availability event can't turn into a disaster recovery event, right? A perfect example is like your storage failed. Technically, all the compute's still there. Like the cluster will still be up and running mostly. Yeah. But you probably are going to want to fail over, right? You're going to want to enact your disaster recovery plan in order to move back to a functional storage system for all of those things. So it's entirely possible for an HA event to turn into a DR event. Mm-hmm. So kind of last week, we talked about things like we want to identify the risks that we're trying to mitigate against. So that way we don't just go off the rails and do all kinds of crazy mitigations or crazy actions that don't really affect the things that we want to protect against, right? So, hey, I want to protect against a single node failure. Okay, does that mean that I need to be doing things like, that I need to have, 500 replicas of the application just to protect against a single node failure? Well, maybe not, but we need to understand what we're protecting against. We also need to do that or understand that for architectural decisions. What I mean by, and I think most virtualization admins probably at this point kind of get this intrinsically, like, am I protecting against a top of rack switch failure? If so, how am I doing that if my OpenShift is deployed to bare metal? Do I have, multiple network adapters that are connected to multiple switches? Am I using, some sort of LACP? Am I using or other bond mechanism in order to provide high availability for those IP addresses inside of the cluster? So just identifying what all of that is, taking that into account, making sure that we do the normal set of stuff associated with high availability. Most of us think of that, especially us old Virt admins like me, think of it at the infrastructure layer, right? And the physical layer. So again, redundant network links, redundant CPUs even, right? And, error correcting RAM, all of those things to protect against cosmic rays, as the case may be. Didn't we just talk about that recently here on the stream?
I think we did.
Yeah. However, all of that being said, sometimes and we talked a fair amount about this last week, much of the HA with Kubernetes and cloud native applications is falling to the application. And this is happening naturally more than anything, or it is a natural evolution of the application, right? As those things that were previously in AWS, right? Application teams who deployed to AWS and Azure and Google and all of these other cloud providers, they Christian, that's a little extreme. So you're like,
Jesus, no.
Yeah. What's the smoking crater, right, example that we sometimes use? Yeah, that's taking it to 11. Anyways, so we want to protect against those things. Cloud native applications do some of that. However, and I'll use the top of rack switch, right? If all of my nodes are in one rack and all of them are connected to one top of rack switch, and that one switch fails, well, no matter how much HA is in the application, if everything is inside of there, I still have a disaster recovery scenario. So that brings us to today. So much like last week. Where I want to start with this is having an understanding of a couple of different things. One, and probably most importantly, is 2 3-letter acronyms that I hope everybody is familiar with. Right. So recovery time objective, RTO, which is, for lack of a better definition or a more terse information definition, is how quickly do you want to be able to recover your application, right? Your cluster, bring everything back. Recovery point objective is how much data you're comfortable losing as a result of that. And sometimes we have to temper expectations of business folks, right? Because they'll always say RTO of now and RPO of 0, right? We want everything to always be up, and we want to never lose any data whatsoever, right? Disaster should be completely and utterly transparent, which is possible. But as we increase the, as we decrease the RTO and the RPO, the complexity goes up, both at the infrastructure layer and at the application layer. So we have to strike that balance. Again, I hope none of this is news for those of us who've been doing infrastructure, who've been doing ops for any length of time. Right? We have probably had to account for this already at some point. Right? Kubernetes cloud native applications aren't that old. Kubernetes celebrated its 6th birthday this year. Chris, I don't know about you. I've been doing this more than 6 years. So we had to do this, previously, and it certainly still applies when it comes to our OpenShift clusters.
Yes.
So with those 2 things in mind, we then need to account for what types of scenarios, right? How much failure am I going to account for in my RTO, RPO scenarios? So what I mean by that is, I'll pick on that top of rack switch single point of failure. Can I, if I am planning for a top of rack switch failure, can I mitigate that through some mechanism? Okay, that one's pretty easy, right? Multiple switches.
Yeah.
What if it's a rack falling through the floor? What if it's a PDU failing and I lose a whole row of racks? What if it's my crack, now I'm gonna forget what the crack stands for. The chilled water units, right?
Oh yeah.
What if my chilled water unit fails and now my data center is running at 140 degrees?
Been there, done that.
Yes, me too. So what are you planning for? How much failure are you planning for? And the next step is, how do we mitigate that against that? And to be fair, some of these things will get lumped together, right? So is there a difference in your disaster recovery plan if it's a row failing or the entire data center failing? Maybe there is, maybe there's not. I've worked with customers before. I was one of these customers who we would spread things out across multiple rack rows. So some things were in the same row across multiple racks. Some things were across multiple rack rows, across multiple racks in each one of those. Because we had, at the network layer, rack row level redundancy. Right? There was in the middle, there was a big switch, and in each rack, there was top of rack switches, so we could tolerate failure at different levels. Same thing with power. We had power at the rack row level. So how does all of this eventually relate to OpenShift and our applications? And I think it's important to take into account a number of different things here. So something happens, disaster happens. We make the decision, right? We got to push the big red button that says, disaster recovery plan, execute. So what needs to be available on that disaster recovery site? What do I need to have there? So, and forgive me if I'm starting at basics here. I'm just trying to level set, right? So first of all, we of course need some sort of hardware. I hope that's obvious, but at the same time, hardware is relative. Maybe hardware is a hyperscaler. Hey, I'm going to recover. I'm going to push my application. My on-prem data center failed. I'm going to push it into AWS, or vice versa. Hey, we do all of our dev test work on-prem, but production gets pushed up to AWS. If something happens, we just stand up, right? We just move all of that production work on-prem. Water mains in the wall. Been there, done that too.
Yeah.
We had a a once every 20-year event, which was shutting down all of the chilled water, right? We had to shut down the chilled water plant in order to clean out the filters.
Ooh.
So of course that meant that we had to shut down basically the entire data center. We kept up core routing and a couple of other things, but yeah, that was a fun one. And all so that the guy could come in and pull the thing out and then scrape it off over a bucket and then shove it back in. 5 minutes worth of work.
5 minutes worth of work, 2 months worth of planning.
Yeah. Anyways, I've also had a water main bust. That was a fun one.
Yeah, I have waded into data centers before. And you know what they usually keep at the bottom of the rack is
PDUs.
Yeah. And power distribution units. Yeah, it's yeah. When all the power is gone and it's just you, the water, and a flashlight.
Yeah. My least favorite one was we had a crack that was adjacent to the racks, and the condensation tray would clog and overflow. Ooh. And so building maintenance's solution to this, so it was not a raised floor. So it was a concrete floor. Building maintenance solution to this was to take some L channel and glue it to the floor and caulk around it. So that way you got basically 2 inches of leeway before it overflowed the L bracket.
Problem. Yeah.
That was.
It is. Yeah. So yeah, I've had incidents where it's like I've had to figure out, we're going to do SNMP traps on every thermal detection, every thermometer in the data center. I want to know each thing's point, and it's just this huge page of temperatures and graphs and so forth, so on. And thermal dynamics, it's weird how they work in the sense of it'll be 7 o'clock and that's when your data center is the hottest, not at the heat of the day kind of thing, because it lags. So yeah, it's super fun to educate people that routers do have an upper level temperature that they operate well at.
Which varies by manufacturer, by the way.
It does wildly sometimes, but yeah, all those manuals, look in the back, they all have these operating temperatures and everything else in them for that very reason.
Yeah, our Hope 9. Yeah, people grown up in a VM world without having to deal with hardware. Yeah.
Mm-hmm.
Yep. I think I talked last week about network admins had to learn about all of this back in the late 2000s of, sure, when it's just a bunch of desktops, talking to Exchange or something like that, and you reboot a router and they lose a few packets, meh. When it's all of a sudden, thousands of virtual machines communicating across NFS or iSCSI and they drop a few packets, that's a much bigger deal. Yeah. So I don't want to get too derailed here. But the important thing is we want to make sure that we have at the DR sites all of the hardware requirements, whether they be literal hardware or moving into something that is, pseudo hardware, a new virtual environment available to us. Importantly, and sometimes not always obvious, right? Remember things like if you're using SRIOV devices, if you're using GPU devices, if you're using, in the case of OpenShift virtualization, right? Making sure that you have in the BIOS or EFI, right? You have the virtualization extensions turned on. Learned that one the hard way too, as a VMware administrator of, hey, look at all this shiny DR hardware that I now have to go in and I have to reboot each one of them, open the BIOS screen, set this thing, wait for it to reboot. It's 15 minutes per server because they boot so slow.
Well, when you have so many drives and so many gigabytes or terabytes these days of RAM, it takes a little bit.
Yep. So, okay. So we've beaten that horse proverbially. So I'll move on to dependent services. So what I mean by this is if you're an Active Directory, organization, making sure that you have domain controllers at that DR site. So you can do things like authentication authorization. So you can do DNS, right? Because usually folks tie Active Directory and DNS very closely together. DHCP servers, right? All of those things that you need to be able to get everything up and running. Where this gets complex is at the next step. So remember, and this is where I'm trying to think of how to phrase this the way that I want. There's kind of 2 approaches here. One is I have an existing cluster on the source site and I'm going to move that cluster to the destination site. Think something like VMware SRM, or literally, and Red Hat virtualization has kind of the same thing, right? I have the data stores mirrored over to the other side, and it uses Ansible to reconnect the data store, reintroduce all the VMs. OpenShift can't tolerate things like IP changes. It can for the worker nodes, but not for the control plane. So DHCP, if it comes up on the destination side and that DHCP server, hey, here's your IP. Even if it's on the same subnet, if it changes, that's going to cause an issue, right? It's going to delay that recovery process. So we have to be aware of all of those dependent services and all of those other things. I'll ignore things like, I'll assume that you have network and storage and all that other stuff up there as well. So this brings me to the next point, which is, okay, let's say that I am, right, I have either a warm or a cold destination cluster. Does it have to be exactly the same? And this is an interesting question. This is one that I don't have a straightforward answer to, right? So my source cluster is running on, it's got 3 control plane nodes. I've got 30 worker nodes. And, let's say altogether it's 300 vCPUs or 300 CPUs worth of compute resources and 3 terabytes of RAM. On the destination side, maybe that's 3 servers, right? It's been, that the hardware on the source side is, 2 generations old. So we need more physical servers to hit the capacity we need. The hardware in the destination side is brand spanking new, right? We just got it off the truck and it's current generation and it has all of the bells and whistles and everything else. Does that affect how your application is deployed? Because maybe I have, a hard anti-affinity rule in place, and I also have it set to have a replicas of 30. What's going to happen there? Is it going to be able to accommodate that? If I have, now let's take it to the next step. Maybe my application team has also put in place limits with the assumption that we'll have, say, 20 of those instances up. So they have it sized so that I need 20 instances of this pod to hit the CPU and memory needs of my application, but my destination cluster only has 3 nodes and a hard anti-affinity rule that is preventing me from deploying any more pods than that of this particular application instance. Well, now I have this ripple effect, right? So these are sometimes important things. Even if on the destination side, I've got the same CPU, the same 300 CPUs, same 3 terabytes of RAM, I might not get a full recovery out of that. So going back to last week, where we talked a lot, we talked kind of at length about the DevOps philosophy of open and honest communication between the teams. This is one of those areas where even if it's a cloud native application, the apps team, as far as they're concerned, they've done everything right. Horizontal scalability, sizing everything right. We don't want to overwhelm nodes. We want to give them the possibility of rescheduling, of descheduling, of eviction, all of this other stuff. They've done everything right. We could have just broken their disaster recovery plan, all because we used new servers.
Yeah. Context.
Yeah.
That always matters.
Yeah. Peter, an untested disaster recovery plan isn't. And that's another way of saying, right, there's a thing in the storage world, right? When you're doing backups are worthless, restores are priceless.
Right. Yeah, exactly. You can have backups for days that are bad.
Exactly.
You don't know until you test them.
Exactly. So yeah, Christian, I see a couple of messages up above, or no, I'm sorry, rhope9 responding to Christian. So yeah, absolutely. Being cognizant, being aware, working with your peers, working with your teammates. I used to tell folks, when I would give presentations at VMworld and other conferences of, hey, you've got this, NFS based storage over here. You've got your VMware data center over here. There's this giant black hole in the middle, also called a network. Go make friends with your network team, right? Bring them coffee and donuts or bagels or something. Let's see, where was I? I got off on a rant. So some less common things. I think everybody tends to think about, hey, I need to make sure that on my destination site, I have the YAML that defines my pods. That may be literal pod definitions. More commonly, I would expect it to be things like a deployment or a resource set, or even an instance of an operand, right? Which brings me to the next point, which is what are all the things that those depend on? If I'm creating an instance of an operand, is that operator deployed on the destination cluster? Have I taken the time to order all of these things so that the operator gets deployed and configured first so that I can then deploy the operand? Right. Same thing for things like, and again, persistent storage, kind of a given. I'm going to assume that everybody is aware that you have to replicate the storage or have some sort of storage available and reintroduce those PVCs. But what about maybe the registry, right? Are you doing pipelines? Have you replicated the registry instances for those containers so that you don't have to go through a full build in order to be able to reinstantiate the application on the DR site? Maybe you incorporate that into your RTO. Like, hey, our DR scenario is we start at 0 and then we launch everything, which means that we have to basically kick off a whole pipeline process, pull the code in, go through a build, go through a full test suite, let it build the containers, push the containers to the registry, let it now deploy, using deployments or replica sets, whatever it happens to be, the application, let it recreate all of the services and routes. How long does that take? Is that within your RTO? And I'll pick on, some of our own stuff. I think OpenShift takes something like 7 hours to build, like end to end.
Yeah, probably with all the operators and everything else. Yeah, it's a lot of threads.
Yeah, and that's not. I think there's also, there's a lot of tests and a lot of other things that go on inside of there. So, do you need JFrog, right? Artifactory. Do you have an Artifactory instance that is holding some of those artifacts, locally? And JFrog is just the one that came to mind because I've worked with them before. But other similar things. Another thing to take into account. Hey, we're using a registry proxy, right? Basically, an inline caching registry. So we're used to a build process taking 30 minutes. Because really all of those registry or all of those source containers, right, the base images are cached locally. At the DR site, are they already cached? What if I have to go up and start pulling them? Oh no, Docker just throttled us.
Yeah.
And
all the bad things.
Very much. And all of this is, me indirectly reiterating the point that I think it was both Peter and rHope9 have made here in the chat, which is test. VMware and SRM did a really cool thing. They've been doing this for a while now of you can basically test your DR plan in a bubble.
Ooh.
And
I did not know this.
Yeah. So if that's an option, if that's something that you're using, it's a great way to test and validate that. I used to, when I worked for a storage vendor, we had a customer that they had 2 sites, one in Atlanta and one it was also in Georgia, but I can't think of the city now. And effectively, they would run 6 months in one location and 6 months in the other location. And twice a year, they would test their DR because they would literally move operations to the other site.
Yeah. No, I worked for a company that did the same thing. We tested DR by actually using it.
Yeah.
Right. Yeah.
So, and last but certainly not least, is there any client side changes that need to happen? So this is one, and we talked about this last week as well. Let me share my screen here.
Your 4-minute warning is now.
Okay. Thank you. Are you who I want? No, you are not who I want. You are who I want. So what I want to share here is, and now I completely lost my train of thought.
You were going to share something about DR. No.
Oh,
clients.
Yeah. Global. Can't spell. So we talked about this last week. And this is a blog post from Raffaele.
That's right.
So this is one of those scenarios. Could be HA, could be DR. Do you need to update something external to include or to point to the new site, the new location? Alternatively, is the destination cluster, let's say it's something that's already running or something that you stood up, does it need to assume the identity, right, the DNS names of the old one? Maybe it's as simple as setting an apps domain, right? So that way your routes have the right, domain name that's being used for them, something like that.
Mm-hmm.
The other thing that I had up here, I had the sizing and subscription guide. This will probably be the last thing we get to.
Yeah.
So the most recent version of the sizing and subscription guide has way down in here somewhere this disaster recovery section. So Red Hat defines 3 types of DR: hot, warm, and cold. So kind of quickly at a high level, hot means that, just like we showed over here, I have the application running in 2 places simultaneously. If something happens in one, right, this goes bye-bye, I seamlessly or almost seamlessly transition over to the second one. So that is broadly what we define as a hot DR system. A warm DR system would be, if we switch back over here, more or less, I have everything running. I can have 2 sets of infrastructure, right? I can have 2 clusters running, but on this destination cluster, so what this diagram calls OCP2, I don't have the app actually deployed, right? Data is replicating. I've got all of the components, all the parts and pieces replicating. Everything is there and ready. I just need to actually deploy the app, let it scale up, flip everything over to the destination side, right? That would be considered a warm DR type of scenario. So cold DR, the last one that we have listed here. So cold DR would be more or less none of this exists. And by none of this, I mean OpenShift wise. That's not to say that you don't have, a vSphere or a Rev environment or an OpenStack environment or physical hardware with all the network connections and everything configured already there. But I need, step 1 to my disaster recovery plan, cold DR plan, is deploy OpenShift, right? That is effectively a cold DR plan.
Cool. Buddy, you got 1 minute.
Yep. So our Hope 9. So we are working on the chat stuff. Chris, if you want to quickly address that.
Would it be possible to get chat available for the videos? Because on YouTube, which seems to be the archive, they can't be viewed. Yes, so that is actually a feature that we're enabling now, thanks to YouTube exposing it to us. But you can always go to our Discord and go to the live stream channel in there, and literally every chat message that's ever happened is there, and it's awesome.
Good point. I always forget that.
Yeah, if you want to go back and check for answers to questions at any given point in time, just go in there and do a search. You'll hit lots of stuff. So yeah. Right. But yes, we are going to start enabling the comments to appear during the replay of the videos, because that is now an option that's available to us on YouTube. So Thank you for pointing that out.
And cool. As you politely reminded me, we are out of time. So
yes,
thank you to everyone who joined us today. My apologies for not being able to get all the way through our topic. We'll maybe spend a little bit of time next week. I'll definitely put everything into our notes for this week. Be sure to keep an eye on cloud.redhat.com/blog for the blog post. Thank you again, Chris, for your help. Thank you to our audience. Thank you for joining us. If you have any questions, if there's anything we didn't get to, please don't hesitate to reach out. Andrew.Sullivan@redhat.com or on social media, Practical Andrew, all one word, just like you've seen in the chat across the various streaming platforms.
Yep. And I'm Chris Short on Twitter and short@redhat.com. And you can always find us on Discord.
Absolutely.
All right. Good chatting with you today, buddy. And all of you out there, pro gamer move on the chat logs. Thank you. All right, coming up next is OpenShift Commons briefing. We're going to be talking a little bit about security. So if you're interested in network controls and deep packet inspection, please join us. Until next week, stay safe out there.